And in the United States, we had found previously that C-section delivered babies had a higher risk of overweight and obesity. But we were wondering whether that was true also in India.
I haven't looked at sedentary lifestyle with microbiome, but there is research showing sedentary lifestyle as being very important for cardiovascular and metabolic health. So I think that would be an interesting.
Processed foods can have a disruptive effect on your microbiome.
Beyond that,
Just making sure that you're trying to limit some of your exposure, I guess, to environmental toxins that you might find in water or other food products. But there's a recent study that looked at fermented foods in particular and compared that to fiber and found that fermented foods actually had more of a stronger effect on diversity of the microbiome and reducing inflammation compared to even a high fiber diet, which we know is healthy.
Dr. Mueller, welcome to the show. And my first question to you is, your research focuses a lot on the gut microbiome. For people who do not know what it actually means, though that is the buzzword now, everybody is talking about gut health, healthy gut, whatnot. So what does gut microbiome actually mean?
Yeah, that's a great question. So the microbiome is something that is being increasingly studied probably, over the last 15 years or so because of the technology that's really allowed it to be studied. So when we talk about the microbiome, we talk about the microorganisms that are living in and on our bodies. That's the human microbiome. Specifically with relation to the gut microbiome, that's the gastrointestinal microbiome, and even more so the microbiome of the large intestine. And the microbiome itself comprises bacteria, archaea, fungi, and sometimes viruses is also included in that. Many times, the studies that are being done right now are using a technique called amplicon sequencing, which focuses on the bacteria. So a lot of the things that you see in the lay press is related to the bacteria part of the microbiome and the functions that they have, how they're altered by the exposures that you have, what you eat, whether you're sleeping well, whether you're doing physical activity and other things, and then how those things are related to your health outcomes, such as obesity, such as type 2 diabetes, cardiovascular disease, but also things like C. difficile infection or other infectious diseases. Those are also things that are often related to the microbiome.
Oh, that's very interesting. And, I've read a couple of papers where you've spoken about how during pregnancy, starts right from there, right in the womb. So you have done a research where you have linked the mother, during the pregnancy, whatever she's eaten and how her gut health has been and how it has impacted in the later in the childhood. So can you just explain the correlation and how important does that become?
Yes, thank you so much for reading some of the work that we've done. So the microbiome during pregnancy, right? We have the gut microbiome, the vaginal microbiome. Those are related not only to maternal outcomes, so they've been related to gestational diabetes risk, preeclampsia risk, risk of preterm birth, but they're also related to the infant health. And why is that so? At the very beginning of life is when the baby is actually exposed to its first microbes. So there's a vertical transmission that can happen between the mother sharing microbes with the baby. And those first microbes can colonize the baby, can help to educate the immune system. So teaching the immune system of that sterile fetus what is a friendly bacteria and what is a foe or a potentially pathogenic bacteria. So it helps to train that, educate that immune system. It also can play a role in educating the metabolic system. It also plays a role in seeding the microbiome of the infant to regulate the mucosal barrier of all of the different epithelial surfaces. And epithelial surfaces, by that I just mean the barriers that are a barrier between your internal organs and the environment that you're exposed to. So your gastrointestinal tract, your skin, those are all epithelial barriers. And so those initial microbes can have a long-lasting effect on the infant. And one example of that is Bifidobacterium infantis, is a particularly important species
that can break down a component of breast milk called human milk oligosaccharide, which human milk oligosaccharides are found plentiful in human milk of all mammals. Humans have more of this molecule, human milk oligosaccharides than any other mammal, and also more types. But infants couldn't actually use that for energy if it weren't for them having a microbiome. So having the certain microbes to break that down is key. And one of those microbes is Bifidobacterium infantis, otherwise shortened up to just be B infantis. And so we're very interested.
There is also a link to autism, right? There is some research which has happened around that as well, that, the gut health is basically one of the reasons they're found that the child, it may not be the only reason, but then has there been any link on that established? Anything of that?
Yeah, so autism is a complex disorder. Yes. It's not something that is my specific area of research, but I can speak a little bit to some of the research that's gone on. One exposure that has been related to autism is maternal infection during pregnancy. Typically, it's a viral infection that has been linked with higher risk of autism, but also, potentially the microbiome and the microbes that are shared could also play a role. It's very tricky, though, to study autism and the microbiome, because with autism, autism is also associated with dietary preferences. Specifically, children with autism tend to have a less varied diet or a less diverse diet, and having a less varied diet is also associated with the microbiome. So it's kind of a chicken or the egg question, where if the child starts eating differently and then you study the microbiome, you don't know whether the microbiome is different because they're eating different foods, or whether the differences in the microbiome actually preceded autism. But it's something that is becoming increasingly recognized as being a potential factor in driving autism, and I think needs to be studied more.
Okay, right.
It's a great question.
Have you actually looked at the kind of foods, because there is so much of diversity, there's different kinds of foods in different regions, right? So have you actually looked at, since we are in India and we're in Bangalore, we're in South India, so is there anything that's specific that you have actually looked into that is actually playing a lot? Because we're seeing an increase in type 2 diabetes and we're seeing an increase in obesity. So has there been any link that you have looked into?
Yeah, so it's a great question. So we've looked into diet in the microbiome in our studies, and we have a couple of different studies going on. One that I think might be pertinent to India is we looked at plant-based dietary index. So individuals that consume more plants in their diet, and there's an index called the plant-based dietary index, and we separated that to be healthy plant-based dietary index and unhealthy plant-based dietary index. And we looked at that in relation to the microbiome because we were interested in whether all vegetarian diets are the same, or whether people who follow a vegetarian diet where they actually eat more plants versus somebody who follows a vegetarian diet where it's more highly processed would impact the microbiome. And what we found was that those that followed a healthy plant-based dietary index actually tended to have more diversity. So there's an increase in diversity. And those that followed a unhealthy plant-based dietary index actually had lower diversity. And so it was very strong and interesting to see this. We published this paper in the American Journal of Clinical Nutrition, but that was using, dietary patterns that are in the US. So doing a similar type of study in the Indian context, I think would be very interesting. And having enjoyed the foods over the last 48 hours, it's been remarkable and has given me a lot of ideas for future research directions. One other thing that is interesting with the microbiome is that we know a high fiber diet is generally good for the microbiome, but there's a recent study that looked at fermented foods in particular and compared that to fiber, and found that fermented foods actually had more of a stronger effect on diversity of the microbiome and reducing inflammation compared to even a high fiber diet, which we know is healthy. So there needs to be more research, I think, also on fermented foods, and some of the fermented foods maybe in the Indian diet.
Our South Indians might be very happy because there's a lot of idli dosas that go on to our daily diet. Our breakfast, probably many of the households start with a fermented idli or a dosa, which is made out of fermented.
I actually had that this morning.
You had?
It was lovely.
Thank you very much. So you worked with MASTI team on a study about, how the babies were born, whether it's the birth method itself, the C-section and the vaginal delivery.
Yes.
Could you discuss, could you throw some light on that particular study?
Sure. So I was fortunate to collaborate with Giri and Deepa and Eunice, and we looked at whether babies in the MASTI cohort were different with respect to different anthropometry or physical measurements of body size. And in the United States, we had found previously that C-section delivered babies had a higher risk of overweight and obesity. But we were wondering whether that was true also in India, a very different context from the United States. And what we found in India, looking at data from the MASTI cohort, was that infants born by C-section, specifically elective C-section, had a higher risk of overweight and obesity compared to infants that were vaginally delivered. Interestingly, we also found that elective C-section delivered babies had higher risk of being shorter or having shorter growth, suggesting that there could be an association not only with being overweight or obese, but also having restricted linear growth or stunting. So that observation needs to be, of course, followed up on. But in India, there's often a problem known as the dual burden of overnutrition and undernutrition, right? So having overweight, but not having enough of the good nutrients. And so whether or not the microbiome plays a role in that dual burden of overnutrition and undernutrition remains to be seen. But the study from the MASTI cohort suggests that delivery mode might, in fact, which disrupts the microbiome, might be involved in that as well.
Okay, that's really interesting. I think we should further look into that study, definitely.
Yeah.
So recent studies have suggested that, each person has a unique unstable gut microbiome. So, if there has been, like when we're discussing about type 2 diabetes, what about the medication itself? Like, can we personalize gut microbiome and actually work around that? Is there anything happening around that already?
That's a great question. This is an area that we're very interested in, and we actually have research funding to look at this. So what you're kind of asking, what we call in the research community, is precision nutrition, right? So whether a diet for you has the same effect as a diet for me is a question, or anybody else, right? And so is a diet specific to an individual, and what about that individual kind of may trigger these differences?
So if we can actually use this concept as a public health in itself to look at undernutrition and overnutrition and things like that. So.
Exactly. Yeah. And so there's been some research to suggest that indeed the microbiome of an individual predicts whether or not they're going to respond in one way to a food or a dietary pattern versus another way. Aaron Segal and his colleagues in Israel first demonstrated that in 2015.
Okay.
And the concept is pretty much, your underlying microbiome, the microbial signature that you have may respond differently to different foods than, the neighbor that you're sitting next to.
Mm-hmm.
So understanding that is something that people are very interested in doing. There are not a lot of studies that have looked at that yet, but I think keep an eye out. You're going to see more studies coming out in the future. And I think it's important to have more representation again from non-United States or non-European studies, because the microbiome of the Indian population is very different from the microbiome of the US population. So really getting context-specific results is important.
What are some of the challenges when you see from the research to actually coming out with a product as such? There are so many products already in the market which claim to actually have healthy effects on your gut, and then there's microbiome which can be generated and things, all of those things. So what is the challenge that you actually see from the research too?
Yeah, so it kind of depends on the challenge from which perspective. As a researcher, the challenge is communicating to the general public about research findings so that the general public can say, this is something I can trust, right? So I usually tell people, if you're thinking about taking like a probiotic, for example, look into the type of probiotic that you're taking, the specific makeup of that probiotic, what species are in that. And then if there's a brand name that's affiliated with that, look to see whether or not they've done the clinical research study to demonstrate that there is a health benefit to that probiotic, sometimes multiple strains. And if there is evidence, seeing whether the evidence is from mouse models or from humans, whether it's a randomized controlled trial or not. Don't take everything as truth because some people may be over exaggerating the claims, right? So it's very important. The example that I'll give is in the United States. Historically, some types of probiotics were there just because they were easy to grow. So certain strains of bifidobacteria and lactobacillus were easy to grow because they were oxygen tolerant species. But now there's a next generation of probiotics that are actually based on evidence from a lot of studies, and they are sometimes anaerobic bacteria, so bacteria that are difficult to grow in oxygen environments. But because of the sophistication of the companies and the techniques that they're using, they're able to grow these products or grow these species and then encapsulate them and give them to you. And I think that those next generation probiotics that are evidence-based have a lot more potential for improving health. So keep an eye out for those products on the marketplace as well.
Okay. Are there any other exciting ways your research is connecting with studies like MASTI and CDLR in India? So, what potential do you see in working with these long-term studies?
Well, that's great. So a great question. Yeah, we're doing some other research looking at other exposures other than diet that I think are potentially important in the Indian context. There's been some research, for example, looking at air pollution exposure and, again, air pollution interacting with our epithelial surface in our gastrointestinal tract and showing that air pollution is associated with the microbiome. And so having a study, where we have very different levels of air pollution and seeing whether that may be a potential explanatory factor for differences in the microbiome is a really interesting area of research. Also, we take in water every single day. So the type of water that you're taking in may also have an impact on your microbiome. And we have some preliminary data from a cohort looking at well water versus city water and finding very strong associations with the microbiome composition. And so extending that to a non-North American population, such as the MASTI cohort, for me is very exciting and interesting. Apart from the MASTI cohort, I know that there's other populations in India and even in your state that might be very interesting to help to understand the microbiome and how that changes, such as the level of urbanization, going from a more tribal cohort to an urban cohort and seeing how urbanization may impact the microbiome, and then starting to take apart those different parts of urbanization to say, what is it that's driving those factors?
Have you looked at lifestyles and climate change per se into this in the same aspect, like, how sedentary lifestyle versus somebody who's very active and, the climate changes that we are noticing these days? So have you looked at any of these?
I haven't looked at sedentary lifestyle with microbiome, but there is research showing sedentary lifestyle as being very important for cardiovascular and metabolic health. So I think that would be an interesting question. And then with respect to climate change, there's many aspects, but I would imagine that there are aspects of climate change, such as exposure to very high heat, as having impacts on microbiome because of differential microbiome growth. But it's not something I particularly have looked at. So it's a great question, though.
Yeah. So what do you think will be the biggest discovery or breakthrough in gut health in the next 10 years?
Well, we're kind of coming to this time right now where we have a little over 15 years of high throughput sequencing data to start to understand, the role of the microbiome in different health outcomes. So translation of those findings into actual meaningful impact for patient populations, I think will start to be the kind of high impact research and other, translational components for people who are actually out there and looking for something that's going to improve their health. There's three different buckets of translation that I think of usually. One bucket is therapeutic manipulation of the microbiome. So taking findings and then saying, how can we change the microbiome to improve health? That's one area. And there's many examples of different probiotics, targeted nutritional therapy, even, microbiome transplants such as fecal transplant or vaginal seeding, which we're doing with C-section delivered babies to improve their health, or at least see whether that can improve their health. So we have therapeutic manipulation is one area of translation. A second area is screening and diagnosis. So I think that the microbiome is going to play a role in helping us to better understand future risk for somebody. So screening, using that for prediction of future risk, and then also diagnosis of underlying conditions that have historically been very hard to understand.
Mm-hmm.
And then the third bucket is the precision medicine angle. So using microbiome as one component to better predict whether somebody's going to respond to a medication, respond to nutrition, in this area of kind of personalized medicine or personalized nutrition. So those are the three areas that I think microbiome will make its biggest impact in the next
I'm sure
5
the
years.
new center for research, which is, the Center for Developmental and Life Course Research at the C Camp and here, is it going to have any impact? Is it going to be, how excited are you to be associated with this new center that is being launched tomorrow?
Oh, I'm very excited. I'm happy to be here at the precipice of this exciting center launch and just be a part of that, continue to collaborate and hopefully come back on future occasions to continue to watch the growth and just see how it can make a bigger impact on the population health of the Indian population. It's a really exciting time.
That's interesting. I have one last question. When I told my colleagues that I'm going to be speaking to you, they had this very simple question. How do I know whether my gut is healthy or not? Give us some, 5 things to actually note down and say that, okay, this is a good gut health. I have a good gut health, or, I can do this to actually improve my gut health. So these 2 things they wanted me to ask you.
Oh, yeah. Well, that's a really tough question to ask. So characterizing the microbiome in terms of and putting it into buckets of good or bad is always a very challenging thing to do.
Mm.
So really the best thing you can do is just kind of monitor your own body and see whether you have good digestive health in terms of your regular or having regular stool, bowel movements, and being in touch with your body if you're feeling like malaise or anything like that. But also just being proactive by saying, well, we know what is associated with a healthy microbiome in general, having a good balance of bacteria. And that includes eating a plant-based diet that's rich in fruits and vegetables, getting multiple colors, eating the rainbow in your diet as much as you can every day. Trying to limit processed foods, ultra processed foods in particular, because the emulsifiers that are used in processed foods can have a disruptive effect on your microbiome. Keeping your fluid intake up, engaging in physical activity, limiting sedentary activity, trying to get adequate sleep, and trying to limit your stress as well. And then beyond that, just making sure that you're trying to limit some of your exposure, I guess, to environmental toxins that you might find in water or other food products or hygiene products as well.
Thank you very much. It was really wonderful speaking to you, Dr. Mueller. Thank you very
Thank you
much.
so much. Yeah.
That is all we have for today. Thank you for watching.